Hi class, so welcome to the next part of the logistic regression implementing it on Python. So for this lecture, what we're gonna do is we're gonna analyze some data from the Titanic, and we're gonna be able to do some predictions with it. So we're gonna look at the passengers ID and then whether they survive or not, and then the the class level they were, some of the names, their sex, their age, and stuff like that. So to be able to make a predictions if they pass survive or not. So this is a classification. Remember, logistic regression is a classification type of prediction. So in here, we're gonna predict whether they pass, whether they survive or not, right? And so for this lecture, we'll be working with the Titanic data set from the Kaggle. This is a very famous data set, and it's very often is a student's first step in machine learning. We'll be trying to predict the classification, survival, or disease. Let's begin. Our understanding of implementing logistic regression in Python for classification will use a semi-clean version of the Titanic dataset. If we use a dataset hosted directly on Kaggle, we may need to do some additional cleaning not shown in this lecture notebook. Okay. Important libraries. We're going to import some libraries for our data. So in here, we're going to use the pandas. So we're going to import pandas as PD. And remember, so we're going to import pandas, and we're going to import numpy as NP. So remember that numpy, to import numpy, is to be able to use the library for arrays, is to be able to translate the data that we collect instead of it sorted as an array. The pandas is to be able to take it into another level instead of using arrays, which is a one-dimensional space, and take it to a multi-dimensional space, kind of like a matrix format, and we refer to that as a data frame. So pandas is going to allow us to be able to use this data frame that allows us to be able to extract information, clean data, and many different in a much faster way. We could have done this without these tools with Python, just pure Python, without importing any of these libraries. But again, because pandas turns every data into a data structure, that takes more space into your memory and takes more time to process it. So it's not as fast as we would do if we use a NumPy or a pandas. And because we're collecting so much data, we're processing so much data, the processing time is super important. So that if you remember back into data structures, having a time complexity efficiency is very important when you write your program. And because in this case, when you're doing machine learning and data science, we are processing ton of data, and sometimes thousands and thousands and thousands of lines. It's so important that your efficiency in your program is really well. So the NumPy turns everything into an array, and then of the same data type, and then the pandas takes it into a multi-dimensional array, into a data frame. Okay, just to remind you why it's important to be able to use these tools. We're gonna use the matplotlib to be able to display information, and we're gonna refer to it as a PLT. We're gonna import our Seaborn, which is another way of being able to display our information. So sometimes we can't our prediction or the data that we collect or analysis that we get, their numbers. Sometimes it's not very easily to for us to visualize it unless we put it in a graph. So both matplotlib and Seaborn allows us to be able to visualize our data and why are we making those predictions as we are. Okay, so just to give you guys a little bit of background of why we're using those imports. And again, those imports packages are already built in Java. So in Python, and we don't need to do them. It's like we're accessing this special tools into importing these special tools into our program so that we can use them. Okay. All right. So now what we're going to do is we need to import the data. So the data is provided to you guys through the CSV file, the comma separated values. Sorry, it's a comma separated value file. So I provided you guys with those files on the canvas, so please download them into your computer and upload them into your project here in OpenLab. And again, remember, we can import data to our project here by many different ways, right? We can import it through a file. It could be a CSV file, it could be a text file, it could be an Excel. We can directly get it from a website, or we can get it directly from an API. So right now we're doing the much easier one, which is just importing the file into our computer and extracting the data. Okay. So the way we're going to extract it and save it, we're going to store it into a data frame using our pandas. We're going to call it train, and we're going to use our pandas data frame, and we're going to read from this CSV file, and our file is called. Now, in order to be able to get the right path, I'm gonna right click. Right, I'm gonna read my data from my training CSV. If I open it, look at this. We can see our information in our CSV file. So those are the first 10 rows, and we can see the columns for each of our the rows: passenger ID, survive, class, what level of the class, like first class, second class, so on, name, sex, age, SIP, SP, parts, ticket, fare, cabin, embark, right? So we can see that information there. So we want to extract the data and put it into the data frame. And the way we're going to do that, we want to make sure that we get the right path, is we can go through if we go through the three lines on the, if we go, and there's 3 lines right there that you will see, and you can copy the path of it, and now I can paste it into my code. Now this is going to allow me to make sure that I'm actually reaching the right location of my file. Oops. What did I do here? I want to put this into quotations. Let me see, quotations. There you go. So because it's a string, right? This is supposed to read a string, and the string is going to be the address location of our file. Now we want to make sure this is run, so we're gonna first run our first cell, which is the imports, and see if there's no problems. So it seems like everything's good. And then we're gonna run the next one, which is to be able to read our file. And now what we're gonna do is we're gonna make sure that we actually have read our file. So what we're gonna do is we're gonna get the first 5 outputs of our file. I'm gonna close this right here, and you can see if I run this, I'm getting the 5 first entries of our data of our CSV file. And so this is a good way to check that you have your information there. Remember, Colab is an interactive programming language where we can actually visually see what we have done per line, instead of the traditional programming style, like what we do in Replit or in PyCharm, or even other like IntelliJ. So we write the whole code, and then later on we run the code, we execute it, and make sure, and then we see how it did, right? And here we can see 1 byte, which is very good for anybody who's a data scientist or a machine learning programmer. So we can see that we successfully have taken out the data. And now what we're gonna do is we're gonna analyze our data. We're gonna explore our data, see if we're missing any part, because we need to make sure that every part of the data is clean, and it has a data. So let's check if it is our data, right? If how our data is clean. So what we're gonna do here is we're gonna use the Seaborn to be able to create a heat map and show us which columns are missing some data. And so what we're gonna do here, as you can see, the yellow stuff, so here, where's my clean this up. Right here, the passenger ID. Everybody, we have an entry for every single row. For the survival, we have every single row. We have an information for the class. We have a row element or entry for every row for the sex, but the age doesn't. So we're missing some data on the age. The Civ SP has every single entry. The parent has every entry. The ticket, the fare, the cabin is missing a lot of data. The embark has practically everything except one of them. So we want to analyze that. So the way we do that, the way we reach that is by using the seaborne heat map. So this is going to highlight the locations where it's missing some data. And what we're going to do is we're going to look at our train data. So we created that train data on the top, right? Our train data. We're looking at our train data. And what we're going to do is we're going to apply the method is null. So we're looking for all the null entries on that data. And we're going to highlight any entry that is false. And we're going to color CMap. Let's spell that. And we're gonna have here a type of colors varies these. Okay, so if we don't remember what this each of these parameters is doing, we can always look at the seaborne heat map. And so it does actually a pretty good job on explaining every single data parameter that we have. The first one is to be able to represent the data. So we put the train, right? We decided to put the train, and we're looking at the train is null. Is null means that it doesn't have a value at that entry. And so the Y ticket labels is false. We can look at that, and it is if we put true, then we're gonna plot the column names on the data frame. If it is false, then we don't plot the column names. And then we have the C bar, which is in which it's an axis in which to draw the color bar. Otherwise, it takes space from the main axis. So we want to put it false, so we just take the space from the main axis. And so we're gonna make both of them false, so we don't show the labels. And then the C bar is to draw the color bar. So that's what we have here. And we draw them, and we can see honestly, I don't know why they're not showing the diagram anymore. That's a good question. I don't know why. This is the right code, but it's not showing it. Anyway, well, we'll move on. And so the next part is we want to be able to see. So we see that roughly 20% of the age data is missing. So from the diagram that we saw before, we need to see that. Hold on. I don't know why it's not showing, but anyways, let's do something else. Let's show train.info. That's another way of figuring out if we're missing some data. Oh, there you go. So I don't know why it wasn't showing for some reason. But anyways, we can see by using the train.info where we're missing some data. So supposedly we're supposed to have 891 entries per column. In other words, from 0 to 880, so that's 891. And we can see that the passenger has 891, survival has 891, the class has 891, The name has 891, the sex has 891, but the age is missing a lot of data. It's about 20% of the data. And then you can see again the cabin is missing a lot of the data, practically almost 3/4 of the data is missing there. So, and then this one, the embark is missing. I think it's missing 2 data there. So we can see here, either using the heat map or the train info, which ones are missing. And now in this case, we can actually even see what kind of data type we have there. Okay, so roughly 20% of the age data is missing. The proportion of age missing is likely small enough for reasonable replacement with some form of imputation. So because there's so little, there's not much data missing, we can kind of fill it in. And there's different ways of filling in that information. But what we're going to do here is we're going to try to find the average age per class and fill it up for the current age, for that age. So we're going to look at the cabin column. It looks like we're just missing for the cabin, we're missing too much information to be able to, use it. So we're just going to remove that column. We're probably going to drop that later. Or change it to another feature like cabin known 1 or 0. So we could either change it to we either have the information about the cabin or we don't have the information about the cabin. So let's continue on the visualizing some more of the data. Let's check out here more information. So let's see how many people survived and how many people didn't survive. So we can do SNS dot set style, and we're gonna have a white grid. So we're setting up a white grid for our graph that we're gonna create right now. And again, SNS for the seaborn, and then again we're gonna do SNS dot count plots. So we're gonna use the graph that counts the data for a specific column. So we're gonna use X to be representing our survive column. From our data train. Now our palette colors, so that will be our colors, will be represented by red and blue colors. So let's see if that works. Oops, something's wrong. Survive, I think I spelled it incorrectly. It's supposed to be capital. So if you notice the name is capitalized, survive. So I was writing in lowercase, so that's why it wasn't identifying it. So we now run it. Oops, something else is missing. It says palette. I wrote paletter instead of palette. So we're gonna make sure that we write palette, and you can see now we can visually see how many people survived the Titanic and how many people didn't survive the Titanic. Okay, so of course there was unfortunately a lot of people who didn't survive, over 500 people, and about maybe around 300 people that survived the Titanic. Now what we're gonna see is we're gonna do the same thing. But we're gonna add a new layer to our columns. So we're gonna separate our survival by their gender. So we're gonna keep the same graph, but what we're gonna do is we're gonna add a hue. Remember from the beginning of the semester, we talked about that a hue allows us to be able to add a new column to the column that we're representing. So it's like separating our a column that we were looking for data and adding another column to separate it. So in this case, we're gonna hue it by the gender, by the sex. And if we run this, we can now separate the people who survive by if they were male or female, or people who died in this case, right? People who died is on the 0. So this is the males, the males, as we saw, as some of you saw in the movie, right? The females were the ones who were given the priority to get into the emergency boat, right? Women and the kids. So that's why you see that most males didn't survive. More males died versus females, and more females survive versus males, right? So that's probably maybe the age. We can see the age differences and see how many of these people who survived were kids. And then we can also separate the people who survived by their class. So it seems like the people who were in first class had a higher probability of surviving, and then they were given boats. And so we can analyze that and see how much in relation with that, right? So how are we gonna do that? We're gonna do the same thing. So instead of doing a hue as the to create a new division, we're gonna use the P class. Let's change this to rainbow. As we can see here, we have people who didn't survive. Sorry, let's change this to people who didn't survive. Were the majority were the lower class people. The people who were in the higher class had a higher percentage of, or were the people who survived more, right? And then it was the second class. Sorry, the third class, because there were more third class people than there were second class people. So even though there were more third class people, they were the ones who died the most. So for many reasons, money, right? People, I'm not sure they were given money or whatever. I'm not sure, right? But maybe also because they were in the lower bottom of the boat, right? Too. So anyway, so we can see and analyze the data based on what we are given, right? And now we can see, we can keep going, and now we can visualize the distribution of the. So now what we want to see is what is the age distribution in the Titanic. So we're gonna use a diagram from the seaborne, and we're gonna use the distance plot. So depending on the value, that's how big the bar will be, and we're gonna use the train data on the age information, and we're going to drop. We're not gonna use any data that does not have a value, so we're gonna drop the null value, and we're gonna have our KDE set to false. That's usually not important. Our color will be a dark red. We're gonna use a dark red. And bins represent how many bins do we want to be able to, how many bars do we want to see in our graph. So in this case, we're saying we want to have 30. Now I'm missing I have an extra quotation there, and let's see if this works. There you go. So if I put this to 80, that's gonna show 80 bars. You can see. So the bins is asking how many bars do you want to see, and that, of course, the more bars you have, the more accuracy you will see. But you can see, you can appreciate a little bit better the distribution if you have a 30, even though it's a little more approximation than anything. So in here, we can see that the majority of the age was probably between 20. Let me do it a little more precise. right? So the age, precisely, the majority was between 20 and 32. That was the majority of the people. So that's how many people. That's how many people were of the age of 20 something, 23, 70 something. So you can see the majority of people were here. And now let's see if we want to. We can also change how colorful do we want to see this graph. If we want to be able to make it a little more different. It really doesn't make any difference, but you can change the color of your graph by making it into a using the alpha. Alpha specifies for the darkness of your color. So we can do 7, and you can see that it's going to represent a much more colorful. Oh, let's actually let me use it. I'm gonna actually use a different graph. I'm not gonna use this plot. The alpha is not represented on this plot, but it's actually represented on a different graph. Sorry about that. That's actually a train age dot history bins is going to be 30, so we're going to keep the same number of bins. Color is going to be the same color, dark red. So this is another way of graphing the same thing, but with a different style. This is using the Seaborn. This is not using the Seaborn. This is just using a normal data frame. This is actually using the data frame tools. And you can see it's the same graph. I can actually just change the color to a little more lighter. So I can do a 0.2, and that will be a lot lighter. You see? But anyways, but I'm just showing you that you can actually represent the graph with the different tools. So what I'm gonna do now is I'm gonna display the SIB SP. So the SIB SP stands for the number of siblings and spouts. So we're gonna figure out how many siblings and spouts does each person was an average per person, right? So we're gonna use the Seaborn count plot, and we're gonna use x equals the sibling spouse. Oops, put a 0 there. Data train. So we're gonna get the data from the train from our train data frame, and then we're gonna graph it. So we can see that a lot of people didn't have a sibling. About 600 people didn't have a sibling or a spouse. But how many people had one sibling or a spouse was 200, and so on and so on. And we can do this with a different way and in a different format using the data frame. So we can use, or actually let's look at the fair. Let's look at the fair, and that's going to represent. We're gonna use the histogram with the color green, and number of bins is going to be equal to 40. The figure size will be the dimensions of 8 and 4. Okay, so we can do that, so we can see that. All right, let's see. All right, we're gonna ignore the cufflinks plots. So I'm not gonna go over this part. We're not gonna do it. So we're gonna skip that cufflinks for plots. Okay. We're gonna go back. We're gonna go down to data cleaning. So we still have a big problem. We haven't cleaned. We just so far have analyzed our data. We saw the relationship between the age and the people who survived, the class that they were on, first class, second class, third class, and the people who survived. Um, and so we saw some information about the age, which were what were the majority of the passengers, but we haven't quite cleaned it. We need to clean the data. We need to make sure that every single data that we have in our data frame before we can start training it has an entry. And we saw that a lot of the sex, gender doesn't have, like 20% of it is missing, and definitely for the cabin, 3/4 of it is missing. So we need to be able to clean this data. So do some feature selections. In other words, select which features we're gonna have. So let me just go back a little bit and remind you guys about this part right here. Every single column is a feature. Okay, this is a feature, 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 feature. So feature selection let us know that what it means is that we need to select which of these features are going to be important for our prediction. Sorry, this is not a feature. This is our label. This is our target. I'm gonna put it in a different color. This is our target. So the red ones are our features. The blue one is our target, our label. And we want to be able to use these features to be able to help us predict if they survive or they didn't survive. Okay, just to remind you guys about that. I know I talked about features before, but I wanted to show you guys in here again what does it mean to be a feature. All right, so we need to clean the data. We want to fill in the missing age data instead of using dropping the missing data age rows. So one way to do this is by filling the mean age of all the passengers that we have. So we can do it by just finding the average of all the passengers and adding them that way. Or what we can do is find the average per class and fill it up for those rows that are missing their age. So that's one way to do it. However, we can be smart about it. This can be done by average age passenger class. For example, here we see here. Let me clean this. This is the first class, and the average age is around 39, and this is the standard distribution and everything. So the range of it. And then here for class 2, the average is 30. And then we saw that in the third class, the average age was 25. Somewhere around 25. Which kind of makes sense, right? So we want to be able to replace this average for any row whose class is first, who has the first class. We want to replace it with, if they're missing a age, we're going to fill in with the average, which is 30 something. And then the same thing for any row with class, the second class, we're going to put it with the 29. And then if they're third class, we're going to fill in with the 24. I think it's 24 or 25. Okay, so that's the idea. So let's see how we can visualize that, how we can make that graph. So what we're going to do is we're going to use the plot fig, and we're going to write the dimensions of our figure equals 12, 7. So we want to have a 12 by 7 size we're gonna use a box plot x equals for our x value will be represented by the class, first class, second class, third class. The y value will be represented by the age, and our data will be coming from our data frame called train, and our colors will be palette equal to winter. We could have done rainbow also, but no, might as well. Let's do this, and you can see that. Okay, I can change this to be smaller. I can change this to 6 and 3, and you can see that it looks way smaller. You can see that changes the size. Or we can change the colors to rainbow, and it changes different colors. Okay. Anyway, so now what we need to do is we can see that the wealthy passengers are in the higher class. They tend to be older, which makes sense. We'll use this average age values to input the base class for age. So what we need to do now is we need to insert for any missing row. If they're missing an age, we're going to pull it in with the average value of their class. So we're going to create a function here. We're going to use some Python functioning. So input the age. And we're going to pass in, we're going to take the columns. And we're going to say, so we're going to pass in a column. So it could be a list of columns. And the list of columns will contain for the first row or the first entry the age. The second column of our list will be made of the passengers class. And what we're going to do, we're going to check if my data frame is null. What we're going to do is from our age, we're going to set the value. We're going to check if the P class is equal to 1. If it's a class, if it's a first class, what we want to do is we want to return the average, which was 37. So what we're doing is here is we're checking if our data frame has a null in our age, then we're gonna check if their class is first class, we're gonna return 7. If it is else if the P class is equal to the second class, we're going to return 29. Else we're going to return 24. And then else we're going to return the actual age. So if it's not null, then we're just going to return the actual name that they have. Now here it's kind of hard to be able to see the lining, but anyways, I think it's fine. All right. So we created this function that's going to allow us to be able to insert elements that we're missing with the actual average. So now what we're going to do here is now we're going to apply the function. So we're going to say train. And then for our age, we're going to be adding information to our age column. So this is saying add my data frame column age. We're going to set that value to my value that I get from my function when I apply the input underscore h with axis 1. So we're passing in those two columns to our function. So to our function here, we're going to pass in those two columns, h and p class. And so we're applying that function input h, so we could define any function that we want, and we can pass in the columns that we need. And then we're going to do it for our columns, because this axis 1. So the axis 1 represents against the columns. Just remember that. So we apply that, and now let's check again our CMap. Let's see if we're able to fix that. So again, we're going to check NS heat map, and we're going to do the train. We're going to check if my train has any null values. Y tick labels equal to false. C bar equals false. C map equals to VDDs. And I wrote something wrong. C map. And you can see now that our age is clean. So we have clean there's nothing missing in this column anymore. Now this one's still missing practically 3/4 of our data. So we need to clean that up. So the way we're going to clean that up is by just dropping it. We're just going to drop that data. So we're going to say train. Oops, sorry. I don't think we need this one. We're going to do train dot drop. We're going to drop that the column. And the column we want to drop is called a cabin. And it is going to be a column. So we're going to do axis equals to 1. And then we're going to change it and save it to the current data frame. So what we're going to do is we're going to call it true. If I don't put true, it's only going to return a copy. It's not going to make any changes. So we want to make sure that in place, right, we want to replace the old train with this new train that is dropping the cabin. And if we check our train head, we will see that it's no longer there. So we don't see anymore the cabin. Or even we can just actually copy this and see that we don't have that column anymore. You can see now it's clean, right? We don't have that missing data. Okay. All right, so then we're gonna do the train.head. We did the train.head, and then we're gonna do any other one that we're missing. And we see that we dropped anything else that was missing. So we only had like two rows that didn't have a embark. So now we drop those 2 rows of data, and now we can see that our data is clean. We need to have a clean data before we can start training it. So that's very, very important that we clean it. Okay, don't forget about that. Usually, most data scientists in machine learning, they spend most of the time analyzing the data and cleaning the data practically maybe about 60% of the time, or 60 to 40% of the time. The time is about doing that. And so now what we want to do is let's check our data. We can check our data another way that is cleaned, right? By doing a train.info. And you can see now everybody has the same amount of data. Remember we had 891, now we have 889 because we dropped 2 rows that didn't have a embark. So now we went down to 889. Right, so remember we had 889, so we look up here, right, 891. But because the embark only had 889, right, we dropped 2 of them so that we don't have to worry about filling in those numbers. It's just so minimal that we can just drop those 2 rows and wouldn't make that much difference. Okay, so that's what we did for that one. And now what we want to do is so now what we're going to do is we're going to create a data frame for the sex, gender, and the embark. So we're going to create a data frame for each one. So we're going to get dummies for the train, and we're going to look specifically for the sex, gender, drop underscore first true. So we're going to remove anything else, and we're just going to leave it as the sex. So if you want to see what we have there, let's run it, and you can see that we created practically a data frame that only contains the sex, either male if it's 1, and 0 if it's a female. Okay, and so we're going to do the same thing for the embark. So we're going to use embark equals apd dot get dummies. That is the name of the method. Train embark drop first equal true. And I'm going to show you guys what the embark looks like. And you can see that it's going to drop everything else. It's just going to leave the embark. All right, so now the next one we're going to do is we're going to create, we're going to drop our, we're going to create it, we're going to drop the sex column, the embark, the name, and the ticket. From our columns, so that's why we need to put 1 and then in place. So we're going to make those adjustments, and so when we see our train, we'll no longer have those in our columns. So if I run train again, I'm missing a parenthesis here. In place. So you can see now that we have removed the sex column, the embark, the name, the ticket. So now we have the passenger ID the survive, the age, the sibling number of siblings, spouse, and parents, number of parents, and fair. So the reason that we wanted to do this is because we need to still clean this data. Let me show you guys why. So notice that the name is not necessary. Doesn't really matter if the name, who the person's name is. So it really doesn't matter for our data. So we can remove this data. This is feature selection. Now, notice that on the gender, we removed it, but we actually need that. That actually made a big difference. But what we did instead is we turned that column, we removed it and make a new column that had a number, either a 0 or a 1. So we turned a string entries into a integer entry. So we remove them and we move and exclude them, right? This column, we removed it, but we generated this other column that only had integers now, 0 or 1. We also removed the ticket because that's just a random number that it's not going to make any difference for us in the determination of they survive or not. The cabin as well doesn't have any specific information about it, so we remove that one, right? And we already have removed that one from before. Another one that was that was important was the embark. Now the embark, what we did is we separated. There's two different options, either S or C. So what we did is we created another two columns for the embark. So either they have it or not. So either they have the embark S or the embark C. So we separated in two columns so that we can have zeros or ones there. So that's part of the feature selection, removing columns that do not have an integer value, and if they do and we need them, then we have to transform it into an integer value. So that's practically what we're doing here. And so now if we go back down here, we have removed the sex column, the embark, the name, and the ticket. And so now we have, as you can see, just integers there. Now we still want to add the sex in there and the embarked there. So we still want to add those columns there. So we're going to do that. So we're gonna define again our train. We already dropped the ones that we didn't like, right? But now what we're gonna do is we're gonna create this new data frame where we're gonna concatenate our train data. We're gonna concatenate our train data with our sex data frame and our embark data frame, and we're gonna place them. This is supposed to be a list. Sorry, a list. So we want to concatenate a list of data frames, and we're gonna place them. We're gonna concatenate them in the axis equal to one direction, which is the columns. And now if we look at our train, you can see that we have the I think I might have done it twice. So let me do this again. So wait, I have to do it from the top. So I'm gonna have to do it from the top to make sure that everything's clear. So I have to run it from all the way to the top. So that because this is keeping track. If I run this drop 6 embark name ticket, it's actually doing it from my latest train. So I have to run this again from the beginning so it starts fresh. And I do this again, right? Notice that I had mail QNS twice. So if I do it again, it's now gonna be the correct one. Mail QNS. Because I actually ran this twice. Notice if I run it again, I'm gonna have mail QNS in the end. You see? And if I keep doing it again, it's because it's doing an update from the last train. So I don't want to do that, so I'm gonna run it again from the beginning. It's just gonna take a little while. There you go. And then we just want to see the head. I don't think we need this one. And this is just gonna be the head, right? Train dot head. There you go. So that's now a clean data. This is what it means to we fill in any null area, and then we remove the column, the cabinet, because it was just completely almost with no data. And then we remove 2 rows because it didn't have the, what was that? I think it was the embark. It was missing the embarked. 2 rows of the embark. Sorry. And then now what we're doing is we're doing a feature selection. We remove some of the rows because they were not making any differences on our data, like the name. It doesn't make any difference. That doesn't tell us anything about it. So we remove the name, we remove the ticket, and then we redefine the sex and embark columns. We remove them, but we add them again as integers, zeros, and ones. So that's a feature selection. And so what we need to do now is we need to start, now that we're ready, now we can start training our data. So what we're going to do here, we're going to use the logistic regression to be able to train our data and be able to make a prediction. So we're going to use from sklearn.model selection. We're going to import our train test split. And then we're going to split our data into X test, Y train, Y test equal to train underscore test underscore split train dot drop. And so what we're doing here is we're going to take our train data, or our rows and columns, and we're going to divide them, some of them to be 80% of them to be, or actually in this case 70% to be our train, our test, sorry, our training data, and then 30% our test data. So we need to split up our data and separate them into different data frames. So again, remember the X train are all the rows with just the features. The Y train is the correct answer. Okay. And then we're gonna have it's going to be our train without the survive. So it will be everything except my survive column. That will be my training data, access, for my column, and then my train, my test sorry, my y values, right? My y values would be coming from my survive survive column. Our test size is equal to 0.30. And then random state is equal to, this is for me to select how do I want to randomize my data. So let me say this again. So we're going to split our data into two categories. Some of them will be for our training and some of them will be for our testing. 70% because we are making it our test size to be 30%, 0.3. That means that 70% will be for our training and 30% will be for our test. Now the first entry data that I'm going to put in here is going to represent my X values. So I'm saying that my X values will be my train without the survive column. The second one will be my train with just the column survive. So that will be my Y value. This is my correct answer. So this is the data I'm going to use to train it. And this is the correct answer that I want. And we want to divide that by 30%. One will be 70%, the other will be 30%. From the sklearn.linear model, we're going to import our logistic regression. So we are importing our model that we want to do, that we're going to apply. We're going to create an object of it. So that will be logistic regression. That's our class. And this is our object logistic model. We're going to use our logistic model to train to fit our data. So we're going to train it. This is training our data. So I'm going to train it with my X train and my Y train. This I'm training my data. And that should be fine. There's no problem there. Now what we're going to do is we're going to find our predictions. We're going to see what our predictions are with our log model dot predict. So now that we have trained it, we're going to see what our predictions are for my test data. Now let's move on to evaluate our data. We have many different ways of doing this. We can do precision, recall, accuracy, F1 score. So we're going to just do precision, recall, and F1 score. So from the sklearn.matrix, we're going to import the classification report. And we're going to print our classification report with our Y test. So that's the actual solution. And we're going to compare it to our predictions. And we can see how accurate each one is. So predictions is 79% for that they survive, 82% accuracy that they didn't survive for the precision. For the recall, 91% that they didn't survive and 62% that did survive. The F1 score is giving us an 85% accuracy on how well did we do for predicting that it was survival, and then how many that didn't survive and how many that did survive. So not so bad. You might want to explore the feature engineering and other Titanic text files. Some suggestions for the feature engineering. Okay. All right, so that's the end of that. Very simple, very same style as the other ones, as the other models that we have talked about. Okay, so I'm gonna stop here. I know I made it a little too long, these two ones, but we'll see. Okay, it was an important system. All right, I'll see you guys next time. Bye.